So, welcome class. My name is Adewumi Ogufuye. I'll be talking about decimals today for JSS1. Now, what are decimal numbers? By definition, decimal numbers are numbers that have a whole number part and they have a fractional part. Let's look at this. It comes like 15.5. You could have 75.12. You could have 158.01. Let's give it a better number. 59. Okay, that kind of instance. So what we have here are decimal numbers. This happens to be the whole number part. It has a whole number. Then you have your decimal points. Then you have the what? The numbers less than 1. They are called fractional numbers. They're called the fractional numbers. Fractional parts. So every as it is right now, every number that is a decimal has, sometimes it could be having a whole number part, like in the case of 1, 2, 3. And other times it might not be, we have 0 point, probably 25. You don't have a whole number part, this is 0. Are you with me? So after the decimal point, the numbers you find after the decimal point, they are lesser than 1. So let's take the definition from the part we have there. We have the decimal number can be defined as a number whose whole number part and the fractional part is separated by a decimal point. The digits following the decimal point show a value lesser than 1. What we're saying is this. After the decimal point, it is assumed to be tenths. Look at this. Let me take a good example. Like, let's say we have 15, or let's not do this. Let's say 6 points. Let's see. Let's say we have 1, 2, and 3. Now, do you know what this is? This is your unit. This is your tens. This is your 100. Now, after the decimal point, this number you have here, we call it tenths. It's 1 over 10. It's 1 over 10 less than 1. The second one we have here is like hundredths. Hundredths with th, like it's 1 over 100 times lesser than 1. Yes, as serious as that. The number after the decimal place is less than 1. The first one is 1/10, like 1/10 the value of 1. The next one after it is 1/100th the value of 1. So the third one here becomes your thousandths. Let's do thousandths. So what we're driving at is this. That for a decimal number, there's always the tendency for you to have a fractional part, a whole number part, and a fractional part. Like in the case of this, the whole number is 615 whole number. But we're not talking about decimal fractions now. We're talking about the decimal numbers itself. In another class, I'll discuss about decimal fractions. So for that reason, if I have this 15.5, because this is a tenth, after the decimal place, if I'm to address this as a fraction, this becomes 155 all over what? 10. You remove the decimal point from there. It has to leave. So what you have here becomes 15, because if 10 should divide 150, you have 15. 10 can divide 150, that's 15. So you have 15 whole number, 5 over 10. So the decimal point you have here, you can see it here, 5 over 10. So 5 over 10 is less than 1. Well, 5 over 10 is still the same as half. So what you have becomes 15 whole number, 1 over 2. And 1 over 2 is the same as what? 0.5 as a fraction. So there's this correlation between decimal fractions and common fractions. But this time around, we're not talking about decimal fractions. And we're not talking about common fractions. We're talking about decimals. Okay, so take note that this 15.5, see what I did? It has a power of 10. It has a denominator of 10. So take note. Now, let's look at this 75. If we take 75.12, do you know what will happen? To get rid of this decimal point, you have to place 2 zeros after the digits. So you are allowed to write as 7512 all over 100 because of the 2 decimal points. Remember, the second one after the decimal point here, this is the decimal point, is hundredths, 100ths. So if you have 2 digits after the decimal point, if you're going to take it as a fraction, you have to make sure you respect the values there and place in 2 zeros with a denominator of what? 0. Of the denominator of 10. But this time around, you're going to have 10 raised to the power of 2, like 100. So if you're taking this automatically, if you divide this by 100, you're going to have a 75 whole number, 12 over 100. That's the meaning. Because if you say 100 times 75, you're going to have 7,500. If you add the 12, you will have this. Or those of us that know how to change mixed fraction to improper fraction and improper fraction to mixed fraction. So looking at this becomes 75 whole number. Now, I believe 4 can go here to give me 3, and 4 can go here to give me 25. So 3 over 25 is the same as what? 0.12. I'm not going into division of fractions, but just get to understand it. Are we there? So if we have numbers like 0.25, what we're going to do will be 25 over 100. Because there's no number here. Just remove the decimal point. Count the numbers you have after the decimal point. It will determine the number of zeros you place there. So this is 0.25 is the same as 25 over 100. Just to show you that these numbers after the decimal point, they are lesser than 1. So that's the decimal point for you, decimal number, which has a whole number part and a fractional part. But in this number tree, it doesn't have a whole number part. So what you end up having, if you divide this to the lowest term, is the same as 1 over 4. A quarter is less than 1, we know that. Are we there? So there's a whole number part, just a fractional part you can see. And in the same way, if we have this last one here, 158, let's just quickly do this as, if we have 158.059, so what you have, if you're changing it to fraction, gives you 158.059 all over what? 1 and 3 zeros. As sincere as that. So if you take it generally, this will give us 158 whole number, 59 over 1,000. So that's what you have there. 158 whole number, 59 over 1,000 as a fraction. So just knowing how to take a fraction, a decimal number, and seeing it in the fractional part will make you understand the relationship between the two of them. They are both the same, but expressed in different aspects, at different times, with different regards, even in algebra, how it's being expressed. So take note of how you change decimal numbers and how you can see them. So you know the first part is a fraction, a whole number, and the other ones after the decimal point are fractions. Are we there? So let's talk about addition of decimal numbers. Ready? Let's add addition of decimal numbers. Addition of decimal numbers. Now look at this. They will tell you 0.436 plus 2.8 plus 13.44. Okay, they give you this to add. Now, if you're going to add decimal numbers, not even fractions, let me not call it fraction. It has a name. It's called decimal fractions. But let's not call it fraction. We're dealing with decimal numbers now. If they give this to you, what you must do in terms of adding it is, you must make sure you arrange it according to that place value. Remember that I told you from here that the last number before the decimal point is in units, your normal units. The next one tens, 100. The next one that follows is 1,000. So after the decimal point, you have tenths. I'll write the question, we'll solve it together so that you see practically. Decimal point uses place values too. So if you're going to add this, remember to do this, 0.436. Wherever the decimal point is, all of them must follow accordingly. So here will give us 2.8 Why this will give us 13. Don't make mistake of it. 13.44. So you can now do your addition like this. Yes, I know what I'm saying. Now, you feel like completing this as 0, 0, and making this a 0. Yeah, fine. Well, okay. Yeah, okay. But the main point is this. This decimal point must be aligned on the same part while respecting the unit, the particular place values of all these numbers. So if you give me 0.436, and you give me 2.8, and you give me 30.44, remember these zeros weren't there in the first place. I said for convenience, so that you don't find it difficult to add, place zeros on those empty spots, in as much as the decimal point is given there. Are you there? So now if you can add this will now give us 6 plus 0 plus 0 is 6. 3 plus 0 plus 4 is 7. 4 plus 8 is 12. 12 plus 4 is 16. You write down 6, you carry 1. You add 1 to 5, that will give us a 6. And this is a 1 here. Are we there? That's the addition of fractions. Now let me give you another example again. This should help. Let's say we have 143.82, okay, plus 21.195 plus 3641.37. Okay. They say we should add these numbers. Look at them. 143.82, 21.195, and 3641.37. Are you ready? Let's add them together. Now, take the first one without being afraid. Say 143.82, okay? You know the place value. The next one is 21 . So you cannot write 21 under 1. It has to come directly under 4 because the decimal point must follow after 21, which is 21 point. Then you write your 1, your 9, and your 5 here. That means automatically you must have to place a 0 there. Just for convenience, it's not compulsory. Then the last number, which is 3641. Remember, 3641 is like 3,641.10307. So you're going to have this as, mind you, this is 100, this is 10, this is units. So that means, permit me to start writing from here as 3, 6, 4, 1.37. So this is what they say I should add up, adding decimal points. I must make sure all the numbers given, even if they give you 5 numbers, make sure their place of values are respected, both in the whole number part and in the fractional parts. Then if you discover, oh, how do I add this one? This one is even easy. You know, your addition is actually done like this. You're doing it like this. So permit me to do a 0 here. That's to cover for this one that has 3 digits. Just make this one a 0 to cover it up. And this last one that has 37, you could just add a 0 here. Please don't add any zeros in front of these numbers. That might cause confusion. You can write 0 here without it being of much importance. So you can do your addition by saying 0 plus 5 plus 5 is 5. 2 plus 9 is 11. 11 plus 7 is 18. Take 1. 8 plus 1, 9. 9 plus 3, 12 plus 1, 13. So we have 3. Put decimal point. This decimal point that you have followed in assembling it. Add 1 here. This will give us a 6. 4 plus 2 plus 4 is 10. You write down 0, carry 1. 1 plus 1, 2. There's nothing here. If you want to place a 0 here, that would not be advisable. I would advise you do that. But if you want to, no problem. So, but I won't do that. I can do my zeros after this one. I know my unit tens, 100,000s, the fractional part, the whole number part. But we are used to it. A lot of you are used to it. So it's the decimal part I just want you to be careful about. So if I add the one I carried from this 10, plus 1, 2, plus 6, 8, then this last 3 will not take its form. So when you're adding decimals, please remember that the decimal point will be a pointer to where you can place all the numbers. It's the first thing you must look out for, the decimal points. They must be aligned in the same way when you're adding numbers. Okay, let's go to subtraction of numbers, of decimal numbers. subtraction. As the same way, they'll tell us to subtract the following. The way you subtract decimal number is still the same subtraction. So what you have will take this form. Number 1, for instance, give us 23.147 minus 9.883. Okay. And number 2, let's say we have 156.21 minus 87.187. Okay, let's work with these two. Solution to number 1. Remember, as I said to you before in the addition, when it comes to the subtraction, make sure the decimal point is of importance to you. Wherever the decimal point, that's where you should start from. Then you place your 9 here. You have your 883. Then you can do your subtraction. The other one was addition, so you can carry it like this. Now, if you have the 7 minus 3 is 4. 4 minus 8 is not possible. We go back to the next number, which is 1. We borrow 1, we add to this 4. It gives us 14. 14 minus 8 is 6. Now, here is no longer 1, but 0. So we come over to 3, we borrow 1, we add 1 to this one, it gives us 10. 10 minus 8 is 2. Then we'll place a decimal point here. Now, here is no longer 3, it has become 2 because you have sent 1 over to this 0 initially. So from this 2, you borrow 1, you add 1 to this 2, it becomes 12. 12 minus 9 is 3. Why this 1 that's no longer 2 becomes a 1? You can drop it here like that. Still the same subtraction like a normal regular subtraction. But only remember that the decimal point must always be what? On the same alignment. They must be on the same spot. The same. Are you there? So number 2. Number 2, very interesting. I think you should look at this. 156.21 minus 87.187. Okay. Remember, it's the decimal point that guides your addition and the decimal point that guides your subtraction. So if I have 156.21 minus 87.18, don't try to choke the number in. Don't force it in. They have a place value. You must respect that place value. Now, which now follows? Recall how we used to carry 8.2 and we added a 0 here. Just because this one has 3 decimal places, we added a 0. This one has 2 decimal places, we added a 0. Okay, look at the first one. 2.8. So add 0.436. Look at 0.436. But at 2.8, we have to add 2 zeros just to cover that blank. 13.44, we have to add 1 0 here to cover the blank of this 6 in that order. So the same way we'll do here. So when you have this, please put a 0 there. Compulsory. You must do that so that you don't miss it out. Now, what we have here, 0 minus 7 is not possible. We'll come over to 1, we'll borrow 1, we'll add it, it becomes 10. 10 minus 7 is 3. Okay. Here is now 0. From this 0, we'll go here, we'll borrow 1, we add 1 to this 0, because it's no longer 1. We've taken it over to this one. So here becomes a 0. But we add 1 here to this 0, it becomes a 10. 10 minus 8 will give us a 2. Okay. Then, here is no longer what 2, but 1. 1 minus 1, you get a 0. Then you place your decimal points on that same line. So 6 minus 7, not possible. You come over here, you borrow 1, you add 1 here, it becomes a 16. 16 minus 7 will give us a 9. So here is no longer 5, but 4. So from that 4, minus 8 is not possible. We'll come here, we'll borrow 1, we add 1 to that 4, it becomes 14. 14 minus 8 should give us what? 6. So this is the answer to the second one. So both for addition and for subtraction, you have one thing in common. You must make sure the decimal points are aligned in the same way.